A chemical equation represents a chemical reaction by showing all of the elements or compounds that combine and react, and all of the elements or compounds that are produced. On the left side of the arrow we have the reactants, and on the right side of the arrow we have the products. When we balance a chemical equation, we are setting out to make the number of each element on the reactant side equal to the number of each element on the product side. The act of balancing means that we will change the numbers of each substance where we need to, so the elements are balanced. What's really important here is that you never ever change a subscript that is already part of a chemical formula in order to change the numbers of atoms. We don't have that kind of authority. The numbers of atoms in a chemical formula are fixed. Sometimes it helps to sketch a box around each chemical formula so you're not tempted to change the subscripts. How we do alter the numbers is by placing a coefficient out in front of a substance that we need to adjust. A balancing coefficient is another type of multiplier, and it applies to all atoms in that substance, not just the one you're trying to change. So here's the example that will work out. When we start the balancing, we'll balance the elements in the following order. First, those that appear in only one substance on the reactant side or in one substance on the product side. Then, other elements in whatever order we want. But the final elements we'll balance are free elements, which are not combined with anything else. This step especially helps to minimize the back and forth that can happen with balancing. Here's some good news. There's a shortcut with polyatomic ions. If a polyatomic ion appears intact on each side of the chemical equation, in other words, its elements don't change into something else, then we can balance the polyatomic ion as a group. Finally, if we keep track of the numbers of each element below the chemical equation as we go along, it also simplifies things. So let's put all of this into action by balancing this chemical equation. First, we notice that all of the elements are one location. In other words, if we look at just the reactant side, iron, hydrogen, sulfur, and oxygen only appear in one location, in one substance, on that reactant side. Similarly, if we look at the product side, we see the same thing, that iron, sulfur, oxygen, and hydrogen, each of those elements only appears in one substance on the product side. The other thing to be aware of is that we do have free elements in this chemical equation. We have iron on the reactant side, and we have hydrogen on the product side. So these two elements, iron and hydrogen, we will balance last. And the other thing that's helpful is that sulfate, SO4, appears intact on each side of the chemical equation, and so we can balance that polyatomic ion as a group. So we'll start by writing each element underneath the substance where it appears, because this is where we're going to do our work to keep track of the numbers. You see that I've written sulfate within parentheses. Now I haven't included the charge there because I'm not keeping track of this as an ion. I'm simply keeping track of the atoms, and I want to count them collectively as a group. So for that reason, the charge is left off. If we go through and just count how many of each atom or group we have before we start, we have one iron on the reactant side, we have two hydrogens, and we have one sulfate group. Moving to the product side, we have two irons, three sulfate groups, and two hydrogens. Now sometimes it turns out that a chemical equation is already balanced, and this is again why we want to write down the numbers of everything, because there might not be any work that we have to do. If we do a quick check, comparing reactant side to product side, we see that at this moment, it only appears that the hydrogens are balanced. We have two hydrogens on the reactant side, and we have 2 hydrogens on the product side. I'm not going to check those off yet because there's a good chance that those numbers are going to change. But you'll see as we go along, we'll put a check mark once we think that we have balanced a particular element or group. So let's start by balancing the sulfate. We have 1 sulfate on the reactant side, 3 on the product side. So in order to balance these, we need 3 on the reactant side. So we'll accomplish this by putting a balancing coefficient of a 3 out in front of the H2SO4. Because that 3 is a multiplier for everything that's there, it's going to change all of those numbers. So the hydrogen now changes to 6, and the sulfate changes to 3. At this moment, it seems like the sulfates are balanced. Next, we can either balance the iron or the hydrogen. It doesn't matter which one in which order. I'll go ahead and balance the hydrogen next. So we see we have 6 hydrogens on the reactant side, 2 on the product side. In order to balance these, we need a 3 on the product side. That changes the number, and now we have 6 hydrogens on the product side. And it appears that we have balanced our hydrogens. Finally, we need to balance the iron. We have 2 on the product side, 1 on the reactant side. By placing a 2 on the reactant side, that changes that number to a 2, and our ions are balanced. Everything checks out with the work, and this is the final balanced equation.